When you look up at the night sky and see the stars, you're actually communicating with messengers from outside of time. These light photons have traveled for years, centuries, billions of years. But from their perspective, no time has passed at all. They are timeless ambassadors. This claim sounds like science fiction, but it's one of the deepest consequences of Einstein's special relativity. For photons traveling at light speed, time stops, literally stops. Now close your eyes and imagine this. Billions of years ago, a photon departed from a star in a distant galaxy. This photon travels through dark space at 299,792, 458 meters per second. It passes through atomic voids, cosmic dust, galaxy clusters, and today, right now, it strikes your retina. For this photon, from its perspective, this journey never happened. The moment it departed, and the moment it hit your eye, are the same moment. Zero time passed between them. As Carl Sagan said, light carries the universe's deepest secret about time. By living outside time, it shows us time's true nature. But how is this possible? What happens at light speed? And what does this teach us about time, space, and reality? In 1905, while working at the Patent Office in Bern, Einstein published special relativity theory. This theory showed that light speed is the absolute speed limit in the universe. One of Einstein's thought experiments. Imagine traveling on a train moving at light speed. You look into a mirror inside the train. Could you see your reflection? According to classical physics, no, because light would travel at the same speed as you, unable to reach the mirror. This contradiction showed Einstein something crucial. Reaching light speed is impossible for anything with mass. Light speed is denoted by c. 299,792, 458 meters per second. Exactly. This isn't arbitrary. It's a fundamental constant written into the universe's fabric. But why is it so special? Because light speed isn't just the speed of light. It's the maximum speed at which causality, information, and change can propagate. The structural limit of space and time itself. Maxwell's equations had shown this. James Clerk Maxwell calculated electromagnetic wave speed in the 1860s. The result matched light speed exactly. Light was an electromagnetic wave. But Maxwell's equation showed something strange. Light speed was independent of reference frame. No matter how fast you move, you always measure light speed as the same. This violated normal physics. Speeds usually add up. If you walk on a train, your speed equals the train speed plus your walking speed. But not for light. Einstein resolved this contradiction radically. Light speed is absolutely constant, but time and space are relative. They change depending on speed. At normal speeds, this doesn't matter. When driving at 100 km/h, time flows normally. But as you approach light speed, strange things happen. First, time slows down. Time dilation. As your speed increases, your clock slows, not just in perception, but really. Physical time itself slows. The Lorentz Factor calculates this slowdown. Gers 1 Pax fruit, 1 minus v quadrat c quadrat. At 90% light speed, Gers 1 Tok Tui 9, time slows by 56%. 1 hour for you equals 2.3 hours for outside observers. At 99% light speed, Gers 1 7.09, time slows by 86%. Your 1 year equals 7 years outside. At 99.9%, Gers 1 22.37, your 1 year equals 22 years outside. At exactly light speed, Gers 1 Pax fruit, time completely stops. Infinite time dilation. This is why time doesn't pass for photons. They travel at light speed. From a photon's perspective, no time passes between creation and destruction. But there's more. Distance changes too. As you approach light speed, distances in your motion direction contract. Length contraction. At 90% light speed, distances contract by 56%. At 99% by 86%. At exactly light speed, all distances in the motion direction become zero. For photons, there's no distance anywhere in the universe. Zero distance between starting point and destination. Consider this. A photon from Andromeda Galaxy, 2.5 million light-years away. It travels 2.5 million years from our perspective. But from the photon's perspective, zero distance between Andromeda and Earth. Zero time passes. This isn't just mathematics. This is space and time's true nature. Einstein called this spacetime. Space and time unified in one fabric. And in this fabric, light speed is an absolute structural limit. For photons, the spacetime interval is zero. Time and space balance out perfectly. Zero spacetime distance between beginning and end. So how do photons experience this? They don't experience anything, because experience requires time. And for photons, there is no time. From a photon's perspective, the moment it's created, it instantly arrives at its destination. No time passes. All universe distances are zero. Past, present, future are the same moment. A photon born in the sun's nuclear fusion instantly reaches your eye. The 8 minutes 20 seconds journey by our measurements never happens from the photon's perspective. A photon from cosmic microwave background radiation, 13.8 billion light-years away, was created just after the Big Bang. It traveled 13.8 billion years from our perspective. For the photon, zero time. These are the universe's oldest messengers. They departed when the universe was 380,000 years old, when it first became transparent. They've been traveling ever since, but for them, no time has passed. The James Webb Space Telescope captures these photons at the end of a 13.8 billion-year journey. But these photons are witnesses to that first moment, memories frozen in time. What does this tell us about time's nature? Time isn't absolute, it's relative. It changes with motion and speed. At light speed, the very concept of time collapses. In Newton's universe, time was absolute. It flowed at the same rate everywhere, but Einstein showed this was wrong. Time is flexible, depending on speed, gravity, energy. At light speed, this flexibility reaches its limit. Time completely stops. But why is light speed so special? Because light speed isn't actually the speed of light. This name misleads. The constant c is a property of spacetime's geometric structure, the maximum speed of causality. C is encoded in the fundamental structure of spacetime. Light travels at this speed because photons have no mass. Massless particles must always travel at speed c. They cannot stop or slow down. The energy-momentum relation shows this. E queried front to 2pc queried front to 2pc queried front to 2pc. For photons, m0, so EPC. This means photons always travel at light speed. If photons had mass, they'd travel slower. Being massless, they always move at c. And at c, time stops. This applies to all massless particles. Gravitons also travel at c. Being massless means living outside time. So what does this teach us? We are massive beings. Time flows for us. Past, present, future are separate concepts, but as we approach light speed, our time perspective changes. The twin paradox illustrates this. One twin stays on Earth, the other travels at near light speed. The traveling twin ages much less.
This isn't science fiction. It's real physics, observed daily in particle accelerators. Accelerated particles live longer. Time dilation is real. At CERN's Large Hadron Collider, protons reach 99.9999991% light speed. Time passes 746.1 times slower for these protons. Near light speed, time nearly stops. Theoretically, we can travel to the future by journeying at near light speed. Travel for 1 year at 99.99999% light speed. And 707 years pass on Earth while you age only 1 year. This shows time's relative nature. Time is flexible, like space. It can be bent, stretched, compressed with motion. But photon's situation is far more extreme. They're completely outside time. Zero time between beginning and end. The universe is frozen. When you look at the night sky, think about these photons. They've traveled billions of years, but for themselves, no time passed. Red light from Betelgeuse, 700 light-years away. These photons departed 700 years ago, but for them that moment is still now. Betelgeuse is a red supergiant, 20 times the sun's mass, approaching the end of its life. Maybe it's already gone supernova, but we haven't received the news yet. Blue light from Vega, 25 light-years away. For photons, departure and arrival are the same moment. Vega is a young main-sequence star, only 455 million years old. Yellow light from Polaris, 433 light-years away. For the photon, zero distance, zero duration. Polaris is actually a multiple star system, a Cepheid variable, whose brightness changes periodically. Each photon is a frozen messenger of its creation moment, transcending time, carrying past to present. From this perspective, light is the universe's memory. It carries records of every past moment. 13.8 billion years of cosmic history preserved in photons traveling at light speed. When Hubble photographs the most distant galaxies, it's looking into time's archives. We don't know how those galaxies look now. We know their state from billions of years ago. Because light freezes time, it preserves the past. The most distant observed galaxy is 13.4 billion light-years away. Its light departed 13.4 billion years ago, when the universe was only 400 million years old. These photons have traveled ever since, an epic journey from our perspective. But from the photon's perspective, no time passed. They're still living in that first moment. This teaches us about the universe's temporal structure. According to block universe theory, past, present, future all exist simultaneously. Time is an illusion. As Einstein said, past, present, and future are nothing but a persistent illusion. The photon's perspective supports this. For them, all times are real simultaneously. Beginning and end merge.
but we experience time sequentially, like a river flowing from past to future. Is our experience an illusion? Maybe time really is multidimensional, and we experience it one-dimensionally. Photons live real time, outside of time. Different perspectives create different realities. From our perspective, time flows, causality works, change is real. From photons' perspective, everything is frozen, simultaneous, unchanging. Both are true. Both are different faces of reality. As Carl Sagan wrote, the universe's secrets look different from different perspectives. Light's perspective reveals time's secret. Light shows us that time is flexible, not absolute, but relative, changing with motion, speed, perspective. At light speed, this flexibility reaches its limit. Time stops, distance becomes zero, beginning and end merge. Photons are inhabitants of this extreme state, beings living outside time. This has practical consequences. Fiber optic communication uses light pulses to transmit data across vast distances. Internet, phone calls, streaming, all depend on photons' unique properties. Laser technology, from medical surgery to industrial cutting, harnesses coherent light. Solar panels convert photon energy to electricity. LED lights produce photons efficiently.
GPS navigation must calculate relativistic effects, both special and general relativity. Satellites experience time dilation due to their speed and reduced gravity. Without relativistic corrections, GPS would accumulate errors of miles within hours. In particle accelerators, beam dynamics account for relativistic effects. Particles approaching light speed gain mass energy, require more force for acceleration. Synchrotron radiation occurs when charged particles change direction at high speeds. Astrophysics uses look-back time calculations. When we observe distant galaxies, we see them in their past states. The farther we look, the further back in time we see. This is crucial for understanding cosmic evolution, star formation, galaxy development. Cosmology relies on light speed limits. Horizon problems in Big Bang theory arise because light hasn't had time to travel between distant regions. Inflation theory solves this by proposing faster-than-light expansion of space itself, not matter moving through space, but space expanding. All these practical applications stem from one profound truth. At light speed, time stops. Photons live in a timeless realm, connecting distant past to immediate present. When you turn on a flashlight, you're creating photons that will experience no time during their journey to whatever they illuminate. When you see sunlight streaming through your window, those photons experience no duration traveling from nuclear fusion in the sun's core to your eye. Every photon of starlight reaching Earth carries information from the past, but exists in an eternal present. The cosmic microwave background radiation filling all space consists of photons that have been traveling for 13.8 billion years. Yet for them, no time has elapsed since the moment of their creation. This reveals something profound about the nature of information in the universe. Every photon is a messenger, a carrier of data from its point of origin to its destination. But unlike any human messenger, it experiences the journey as instantaneous. The message and its delivery are simultaneous from the photon's perspective. Consider what this means for causality. When we say light from Alpha Centauri takes 4.37 years to reach us, that's true from our reference frame. But the photon creating that light perception in your eye has experienced zero travel time. The star's nuclear fusion event and your visual neuron firing are the same moment in the photon's reference frame. This challenges our intuitive understanding of cause and effect. Events separated by vast distances and long times in our frame are simultaneous in the photon frame. The universe becomes a block where all events connected by light rays exist in the same eternal moment. Perhaps this is why light has such significance across human cultures. We intuitively sense that light transcends normal temporal boundaries, connecting us directly to distant sources. When ancient humans looked at stars, they were not just seeing distant suns, they were participating in a timeless communion with cosmic events. When you look at the night sky, remember this reality. Every starlight you see is a timeless messenger, reaching your eye after billions of years of travel, but from its perspective, no time passed. These photons carry the universe's deepest secret. Time is relative, dependent on perspective. At light speed, it takes on a completely different meaning. Maybe this teaches us humility. Our time experience isn't absolute reality, it's just the perspective of massive, slowly moving beings. Photons live a different reality, outside time, beyond distance, bridging beginning and end. Light shows us, reality depends on perspective. Time isn't absolute. The universe's fastest messengers carry time's deepest secret. As Carl Sagan said, light carries the universe's conversation with itself to us. And in this conversation, time is merely a matter of perspective.